Alright, hello, my name is Tyler Tuttle, and this is my problem. NO and H2O arrow, which is like the equal sign or the balancing equation sign. It's also the zap zone. NH3 and O2. The first step to balancing an equation is to add invisible ones. You need to add an invisible one here, 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 here. That's all the invisible ones on the reactant side. And now on the product side, you need to add invisible ones here, here, and here. Now that you have your invisible ones in place, you can start to draw your structural formulas. So the structural formula for 1N1O1 is NO. The structural formula for 1H2O1 is HOH. And now we have the zap zone, the arrow, which represents the zap zone. We have, on the product side now, we have N, H, H, H. And then over here we have 1, O2, so O. Now that we have that, we can convert these structural formulas into ball and stick model, which you need the atomic mass. So the atomic mass for N, nitrogen, is 14.0067. The atomic mass for O, oxygen, is 15.9994. And the atomic mass for H, hydrogen, is 1.00795. So now that we have this, we can convert NO into NO, and we can convert H2O into H2O, and we can convert NH3 into NH3. We can convert O2 into O2. Now that we have all of these here, we can start to balance our equation. So let's start with the nitrogen. We have one nitrogen on the reactant side and one nitrogen on the product side. That means the nitrogen is balanced. Now we can go to the oxygen. We have two oxygen on the reactant side and two oxygen on the product side, which means the oxygen is balanced. And now we can go to hydrogen. We have two hydrogen on the reactant side, but three hydrogen on the product side, meaning we need to add more hydrogens to the left side, the reactant side, the left side. So we can add another molecule of H2O, because you can only change the coefficient when you're balancing equations. You cannot change the subscript. You can only change the coefficient. So now we check again. We have 4 hydrogen atoms on the left and 3 hydrogen atoms on the right. So we need to add another molecule of ammonia, NH3. So now we have 6 hydrogen atoms on the right and only 4 hydrogen atoms on the left. So we need to add yet another molecule of water, H2O. Now the hydrogen atoms are balanced. 6 on the reactant side and 6 on the product side. Now we can go back. Check the nitrogen. We have 1 nitrogen on the reactant side and 2 nitrogens on the product side, meaning we need to add 1 more to the product side. Now we have 2 nitrogen atoms on the reactant side and 2 nitrogen atoms on the product side. Now we're good there. Now we can check oxygen atoms. 5 oxygen atoms on the product side and only 2 on the, five oxygen atoms on the reactant side and only 2 on the product side, meaning we need to add more to the product side. Now we have 6 Now we have 6 oxygen atoms on the product side and 5 on the reactant side, meaning we need to add more to the reactant side. So we can take another atom of H2O, and now the oxygen atoms are balanced, the nitrogen atoms are balanced, but the hydrogen atoms are not balanced. We have 8 hydrogen atoms on the left side, the reactant side, and only 6 on the right side, the product side, meaning we need to add more to the product side. We can add another molecule of NH3, making us have 9 hydrogen atoms on the right side, the product side. So now we need to add more back to the left side, the reactant side. We can add another molecule of H2O. Now we have 10 hydrogen atoms on the left side, which is the reactant side. So, and only 9 on the product side, meaning we need to add one more molecule of NH3. Now we got one more atom of NH3. So now there are 12 hydrogen atoms. There are 12 hydrogen atoms on the product side and only 10 on the reactant side, meaning we need to add one more H2O molecule. So that means we now have 12 hydrogen atoms on the left side and 12 hydrogen atoms on the right side, meaning the reactant and the product are now balanced. But now we can go back and check. Do we have the nitrogen atoms balanced? No, there's only 2 nitrogen atoms on the reactant side and 4 nitrogen atoms on the product side, meaning we need to add 2 more nitrogen atoms to the reactant side. Now we have the nitrogen atoms are balanced, and now we need to check the oxygen atoms. We have 10 oxygen atoms on the left side and only 6 on the right side, meaning we need to add more to the right side. Now we can go back and check. Let's see. We have 10 we can start with nitrogen. 4 nitrogen atoms on the reactant side, 4 nitrogen atoms on the product side. 10 oxygen atoms on the reactant side, 10 oxygen atoms on the product side. 12 hydrogen atoms on the reactant side, 12 hydrogen atoms on the product side. So now we can go over here and write our final product. So now we need to count. How many do we have? So first, this is the first molecule. We have 4 N1O1 and 6 H2O1. And we can zap it to make 4 N1H3 and 5 O2. So that's our final answer. 4 N1O1 and 6 H2O1. Arrow, which is the equal sign, the zap zone, and the balancing sign, equals 4 N1 H3 and 5 O2. Thank you. How long was that?